Artificial general intelligence? Not so fast. The race toward artificial general intelligence is often portrayed as an inevitability, a straight path from today's large language models and deep learning systems to machines with human-like cognition. Optimists claim that once computation reaches a certain threshold, human-level reasoning and consciousness will emerge automatically. But this vision risks oversimplifying the profound complexity of human intelligence. Human behavior and performance are not just the outcome of abstract logical processing. They emerge from the full interplay of biology, emotion, environment, and even subtler factors that science is only beginning to explore. If AGI is to be truly general and not merely a brittle facsimile of thought, it must account for the same vast tapestry of influences that shape human experience. This essay explores why AGI cannot be built without considering subtle human characteristics, ranging from hormones and gut feelings to collective consciousness and cosmic forces, and why this makes the path to genuine AGI far more complicated than most technologists admit. The biological substrate of intelligence. Sensory inputs, internal and external. Humans process an extraordinary spectrum of signals. External sensory data, sight, sound, touch, taste, smell, feeds the brain a stream of environmental information. But equally important are internal signals, proprioception, interoception, and the body's constant updates about oxygen levels, hunger, temperature, and more. Together, these form a multimodal, embodied context in which intelligence arises. Today's AI systems, by contrast, are disembodied. They consume text, images, or structured data, but they do not feel hunger, breathlessness, or bodily tension. Without these layers of feedback, their understanding remains abstract. To model human-like intelligence without integrating bodily sensation is akin to simulating flight without air. Sympathetic and parasympathetic dynamics. The nervous system operates in balance between the sympathetic branch, arousal, fight or flight, and parasympathetic branch, rest, digestion, recovery. This push-pull shapes not only physiology, but also thought and decision-making. Stress narrows perception and accelerates reaction, while calm states broaden creativity and empathy. Human cognition is inseparable from these fluctuating states. An AGI modeled only on rational problem-solving might replicate chess strategy, but it will miss the deeper rhythms of human judgment that arise from nervous system modulation. Hormones and neurotransmitters. Hormones like cortisol, oxytocin, and testosterone, along with neurotransmitters like serotonin, dopamine, and GABA, profoundly affect behavior. They regulate mood, trust, aggression, and motivation. These chemicals are not peripheral. They are core to intelligence as we know it. For example, dopamine not only reinforces learning, but also governs curiosity and exploration. Without an analog to such biochemical feedback, AGI risks becoming a sterile calculator, capable of inference, but incapable of the motivational dynamics that make humans agents. Intelligence beyond the brain, gut feelings, and the enteric nervous system. The gut brain, a network of neurons in the digestive tract, contains roughly 500 million nerve cells. It influences emotion, decision-making, and even cognition. Humans routinely speak of gut feelings, as if intuition resides in the viscera, and neuroscience increasingly confirms that this is not metaphorical. For AGI to claim human-like generality, it would need to model such distributed intelligence, where cognition does not live in a single locus, but emerges from multiple centers of processing, heart math and cardiac neurons. The heart also contains specialized neurons, forming what researchers sometimes call the heart brain. Heart rhythms influence emotional regulation, perception, and even higher cognition. Practices like HeartMath attempt to harness this connection between cardiac coherence and mental clarity. If an AGI system reduces all intelligence to cortical equivalents, it neglects the subtle but essential contribution of bodily intelligence. Social and emotional dimensions. Emotions, positive and negative. Intelligence is not just problem-solving, it is shaped by emotional tone. Joy, grief, anger, and love create different modes of thought, different creative possibilities, and different social outcomes. Positive emotions expand receptivity and resilience, while negative ones heighten focus and caution. AI today may classify emotions from text or facial expressions, but it does not have emotions. To approximate human-level generality, AGI would require synthetic equivalents of these shifting emotional states integrated into its reasoning. Pain and pleasure. The hedonic system, seeking pleasure, avoiding pain, is fundamental to biological intelligence. It drives survival behavior and motivates exploration. Pain warns, while pleasure rewards. An AGI without a hedonic compass might calculate optimally, but lack the motivational scaffolding that makes human intelligence adaptable and purposeful. Social inputs and collective context. Humans are deeply social. From birth, cognition is sculpted by interaction, language, culture, norms, and feedback from others. Intelligence cannot be divorced from social context. Even solitary thought draws upon collective constructs like language, metaphors, and cultural frames. For AGI, modeling isolated reasoning may be easier, but true general intelligence must embed itself in networks of social exchange and cultural meaning, beyond the individual. Non-local information and collective consciousness. Carl Jung spoke of the collective unconscious, a reservoir of archetypes and shared symbols. Modern physics and parapsychology hint, controversially, at non-local connections in consciousness, where minds might be subtly entangled. Whether or not these theories prove empirically solid, they reflect a long-standing recognition that intelligence transcends the individual. AGI research, by contrast, is often reductionist, ignoring collective dynamics. Yet phenomena like cultural evolution, meme propagation, and social contagion demonstrate that intelligence emerges not just from one brain, but from the interplay of many, collective unconscious and shared patterns. The collective unconscious provides the scaffolding for myths, dreams, and symbolic reasoning across cultures. These deep patterns shape behavior and meaning-making in ways an isolated AI would not replicate without cultural immersion. Cosmic and environmental influences, forces of nature. Humans are not sealed systems. Our moods, productivity, and creativity respond to the natural environment, sunlight, seasons, weather patterns. Circadian rhythms synchronize with day and night cycles, planetary alignments, and cosmic energies. Although controversial, traditions across cultures have linked planetary alignments and cosmic cycles with shifts in human behavior. At minimum, phenomena like solar storms and geomagnetic activity do affect biological rhythms, sleep, and mood. More speculative is the notion that galactic energies influence consciousness, but ignoring these possibilities entirely risks prematurely narrowing the scope of inquiry. Movement of the galaxy. On the grandest scale, Earth's position in the galaxy changes continuously, potentially shaping the subtle background conditions in which consciousness unfolds. Whether metaphorical or literal, these cosmic influences remind us that human intelligence is embedded in the cosmos, not isolated from it. Why I cannot ignore these dimensions. The prevailing paradigm in AI assumes that scaling computation and data will automatically yield general intelligence. But if intelligence is not merely abstract reasoning, if it emerges from hormones, nervous systems, emotions, social interaction, and even cosmic rhythms, then current AI trajectories are missing essential ingredients. A machine that manipulates symbols flawlessly but does not know stress, hunger, love, or awe cannot be considered general in the human sense. It may achieve narrow brilliance, but it will lack the embodied, relational, and cosmic integration that defines human intelligence. Conclusion. The quest for AGI is one of the most ambitious undertakings in history, yet optimism must be tempered with humility. Human intelligence arises from a matrix of biology, emotion, society, and environment so rich that even our best science cannot yet explain it fully. To replicate this in machines may be possible someday, but not through computational brute force alone. A true AGI would need to account for sensory integration, nervous system balance, biochemical feedback, gut and heart intelligence, emotional depth, social connectedness, collective unconscious, and even cosmic influences. Until AI research acknowledges these subtler dimensions, talk of imminent AGI remains premature.